Right, today's lesson, we're going to be looking at combustion and fuels. So the first thing that you need to worry about is what a fuel actually is. So a fuel is a substance that releases some sort of energy, usually heat, when it burns. That's what a fuel actually is. Substance that releases energy when burned. So for example, wood, petrol, paper, if you burn some paper. Now, you need to be aware of the difference between complete and incomplete combustion. So let's write about that first, what the difference is. So we have complete combustion. Let's start with that. So complete combustion occurs when there's plenty of oxygen. So everything can fully combust. So when you combust something, it'll combust with oxygen. Now, because we're dealing with combusting hydrocarbons, let's pick an alkane. So propane, remember CnH2n plus 2. So 3 times 2 plus 2 is 8. Plus oxygen, arrow. Now, the products of complete combustion are always going to be the same if you're dealing with a hydrocarbon. They're going to be CO2 and H2O. And the way that happens is that carbon burns with oxygen to make CO2, and hydrogen burns with oxygen to make H2O. Okay, that is the basis of it. Now, when you balance this, luckily, you can use the Cho method that I mentioned earlier in the balancing equations lesson. The carbons first. There's 3 here, so we put 3 here. There's 8 of these, so we put 4 times 2 is 8. So the first 2 are balanced. Then the oxygens, there's 2 here. Here there's actually 6, 3 times 2. And don't forget 4 times 1. That makes 10 in total, 6 plus 4. So you must put a 5 here to make 10. Let's do one more example. Let's pick C6H, 14, because it's 6 times 2 plus 2. So you lay it out like this. Carbons first, 6, 14, so 7 times 2. Add up your oxygens, 12 plus 7 times 1 makes 19. So this must simply be 19 over 2. Now you might think that's ugly. So 19 over 2 is actually 9.5. Do not be afraid to use the 0.5. The mark scheme will allow it, and they'll always allow these multiples. If you don't like it, you can double everything. But then you would get 2 in front of this, 18, 12, and 14. Much bigger numbers. So I much rather prefer the 0.5 system. Next, we need to look at incomplete combustion. And the difference is that this occurs when there's a lack of oxygen. So there's not enough oxygen for the reaction. And the products still include water, always, and /or carbon monoxide, CO, or just carbon, which is soot. Now, carbon monoxide is toxic. They call it the silent killer because it is odorless, so it has no smell, and it's colorless, so it has no color. The only way to detect it is using a carbon monoxide alarm. So you should have one installed near your boiler, about 15 centimeters height. It's very important. The reason it's toxic, it can eventually kill you if you have enough exposure to it, is that it binds to hemoglobin, you all do biology, and stops blood carrying oxygen. It basically binds in your red blood cells to the hemoglobin instead of oxygen. So then you just won't have any oxygen and you die. For chemistry purposes, you can just say toxic or poisonous. I would say toxic. Let's see, in the syllabus, In syllabus, they wrote actually poisonous. So in the Edexcel one, they wrote poisonous. You can't say harmful because harmful doesn't imply death, but toxic and poisonous do. You're not required to know references to hemoglobin, but you should know that it stops the blood carrying oxygen. That's what the syllabus says. So when you balance these equations, let's try it with the same one, C3H8 plus O2. Now I'm going to put CO plus H2O as my products. You don't put all three. Even if the CGP book puts all three, that's theoretically wrong because those are separate reactions. Overall, it might make all three, but when you write individual reactions, don't do that. Look for clues in the question. If the question says a poisonous gas was produced, then you know it's CO. If they say a black solid is produced, then you know it's C, which is soot. So if we practice this one, the same Cho principle, there is 3 here, so we put it 3 here. There's 8 here, so we do 4 times 2. And then we add everything up. 3 times 1 plus 4 times 1 makes 7. So this has to be 3.5. Again, I like the 0.5 system. If you don't like it, you have to put 2, 7, 6, and 8. Alternatively, you could do it with just soot. So C3H8 plus O2 makes C, which is soot, plus H2O. The H2O always forms because the H hydrogen burns easier than the carbon. So again, there's 3 here, so you put a 3, Cho method. There's 8 here, so you put a 4. Then you add up all the oxygens. Now this one has no oxygens, luckily, just this one. So 4 times 1 is 4. So you put a 2 here, because 2 times 2 is 4. So in this example, you can see there's only 2 oxygens. In this one was 3.5, and in this one was 5. So complete combustion, plenty of oxygen, had more moles of oxygen. This had less, and if you have even less oxygen, that's when you just get soot, because the carbon just cannot burn with the oxygen. Now for carbon dioxide, I forgot to mention, you should obviously know that it's a greenhouse gas, and it causes global warming. So you got the ice caps melting, rising sea levels, weather conditions changing all the time. That's a separate topic, actually, later on. So for now, that completes, I'll save it, the bit on incomplete and complete combustion. So next, we need to continue with the pollutants. So I've saved it, I'm going to rub it out. I'm actually going to continue with the pollutants. So we need to worry about a few more pollutants and what they do. Now, the carbon or soot, I never told you what it does. So carbon / soot. This will actually cause, this is actually going to cause global dimming. So global dimming is when the sunlight is essentially being reflected by all the pollutants floating in the air. So it appears dimmer. Quite often happens in London. So remember, this comes from incomplete combustion. Now, the next pollutants you need to talk about or know about is NOx and SO2. Those are the next 2 that you need to know. So NOx, X means 1 or 2, basically. So it can either be NO or NO2. How does it form? It forms when nitrogen reacts with oxygen, as the first mark, at a very high temperature in the car's engine, essentially. Don't say very hot, because we've had a long discussion about these with like examiners, and hot is subjective, so you got to say high temperature. So essentially N2 plus O2 is forming NO. There you go, balanced. Now, what is the problem of this is that NO can form acid rain and is a respiratory irritant. So it's not good if you have asthma and things. How does it form acid rain? Well, NO reacts with H2O, which is the rainwater, to make HNO3. Okay, but that's obviously not balanced. So to balance it and make it slightly easier for ourselves, let's see. We've got HNO3 here. So we could put 2 here. It's a bit messy now. Let's do that again. NO can react with rainwater to make HNO3. Put a 2 here and put a 2 here. Let's see what happens. It's balanced. 2 H's, 2 H's, 2 N's, 2 N's, 2 times 3, 6 oxygens. 1, oh, it's not balanced. 1 plus 2 is 3. That doesn't balance. So that's a bit of a sticky point, actually. You can use NO or you can use NO2, but unfortunately, if I do this, it makes 5 oxygens, which is still not correct. So I'm going to come back to balancing it in a second. Let's just finish the SO2 one. So the SO2 one, first of all, you need to know how SO2 forms. So the way it forms is that hydrocarbon fuels have sulfur impurities in them. So there might be traces of sulfur present in the actual hydrocarbon. So what happens is S plus O2 makes SO2 at a very high temperature again. And then what's bad about SO2 is that it can contribute to acid rain. That's the main actual contributor is SO2. So SO2 reacts with rainwater and it actually makes H2SO3, which is called sulfurous acid, not sulfuric. But then the H2SO3 is very quickly oxidized by oxygen in the air. Put a half here, and it makes H2SO4, which we normally call acid rain. In the old syllabus, we used to say that sulfurous acid was the acid rain, but now you can just say that you don't even need to give the equations nowadays. You can just say SO2 and rainwater react to form acid rain because there will be oxygen in the atmosphere. And it's also a respiratory irritant. So acid rain and respiratory irritant. Okay, now. Right, so going back to this one, how to actually form the equation, not that you need to worry about it, but it actually, we were trying to balance something that was an incorrect equation because we forgot to take into account that oxygen in the atmosphere is present, just like we took it into account here. So what we need to do actually is do NO2, let me just get the pen, NO2 plus H2O, we have to do, plus we need to add oxygen plus O2. And we're still going to make HNO3. But to balance it, we can now put a 2 here, since there's 2 hydrogens here. And there's 6 oxygens here. But there's 2 nitrogens. So we need a 2 here. So now we have 2 plus 4 is 6. Plus 1 is 7. So that obviously would be a problem. What actually happens is that you get a combination of HNO3 and HNO2, which is the nitrous acid. Then I think that is going to now solve our problem. So if we look at balancing this, we've made a big deal out of this, but we have two H's here, two H's here, two N's here, two N's here, 5 oxygens here. So 4, if we put a half here, plus 1 is 5, plus 1 is 6. Now that's a problem as well then. We can actually remove the oxygen here altogether. That's the solution, because the NO2 has actually come from NO being oxidized. So NO plus half O2 actually makes NO2 in the first step. Then the NO2 reacts with the water, and that actually solves all the problems. So these will be your two equations if you're ever asked to do it stepwise. But as I said, that's not going to be examined. The main thing you need to know is that NOx causes acid rain, and that SO2 will cause acid rain. Okay. That is the main pollutants done. We've done carbon dioxide, and we've also done NO and SO2. I'll save this. And next lesson, we were going to have to look at what cracking is and gently introduce the alkenes. Okay, so see you next time.